Thrive Bioscience takes a huge step in the evolution of cell biology by combining a state-of-the-art cell imager with advanced analytic software. CellAssist is a paradigm shift, enabling deeper insight than ever before possible while documenting your lab's workflow and greatly improving the reproducibility and accuracy of your imaging and cell culture. With most imagers, you manually focus and take one or just a few best images. CellAssist in minutes captures many hundreds to thousands of images over the plate and at many different focal planes. Then automatically selects the best images for you, while also saving all of the other focus increments. As biologists often greatly benefit by later reviewing their samples at different focal planes, CellAssist gives you the option to review and zoom into any portion of any well and to reselect any of the different focus increments at any time, now or in the future. And CellAssist's advanced imaging algorithms provide clear, precise imaging across the well every time, ensuring accuracy and repeatability. Your work is always saved and can be revisited at any time. The CellAssist system consists of two main components. The first component is the CellAssist instrument. It's operated by the included tablet, which allows you to set up your projects and review images within minutes of starting a scan. The instrument sits in the cell culture lab and captures all of the images and data. The second main component is the analysis workstation, which can be placed anywhere either inside or conveniently outside the lab. The analysis workstation is based on a powerful computer that is optimized for analyzing the data and images that the CellAssist instrument captures. After the CellAssist instrument captures the images are available on the tablet and are also sent to the workstation via the Thrive network, a dedicated network for the CellAssist system, which can be run wirelessly or hardwired using standard Ethernet cables. When in the lab, you typically operate the CellAssist instrument using the supplied tablet with CellAssist software. You define plates and cell lines for your experiments, apply conditions, and control the imaging functions of CellAssist. On the tablet, your work is saved in a standard file structure by file name and folder. You simply select the type of plate you want, and add the cell lines. With CellAssist, in addition to cell lines, you can also define and track all the conditions used in your experiment, such as the media, reagents, drugs, nutrients, even protocols can be defined and saved within the project, and be accessed from other projects as well. All of your work is saved. Later, when you're making your plates, CellAssist is your guide every step of the way. A barcode label is attached to your plate. CellAssist uses these barcodes to track the plates automatically within the system. No more sticky notes that become detached. No more writing on plates with markers or fumbling through menus. Each time you insert a plate into CellAssist, that plate's screen is called up for you automatically, ensuring accuracy and reproducibility. With CellAssist, you'll always be on the right screen. Speaking of barcoding the plates makes your workflow much easier than before, but CellAssist doesn't stop there. With CellAssist, you can barcode virtually any part of your workflow. Consumables such as reagents, media, rinses, drugs, hoods and incubators, personnel, protocols, lab notebooks. Virtually anything can be barcoded and entered into the system. Once entered into the system, the barcode input is automatically timestamped and entered into a tracking history every time you scan its barcode. All barcode events are listed in the tracking table and can be easily searched and filtered. The CellAssist barcode reader, by scanning and recording the user, locations, equipment used, reagents, and media, has tracked the workflow. CellAssist offers several options for capturing images from your plates. You can scan a smaller portion of the well to save time, or scan the full well. Select between 4x or 10x to increase the resolution and detail of the image. CellAssist offers both phase contrast and bright field illumination options. Once you've configured your scan, tap the Scan button and CellAssist begins the imaging process. As CellAssist images the wells, the images become available on the tablet. Here you can view the images, pan, zoom, use the ruler to measure your sample. It follows your zoom and it automatically readjusts its increment depending on the length you're measuring. You can select a region of interest on a 4x image and perform a 10x scan on just that region. As soon as the images are all complete, they're sent over to the workstation for full analysis. Scans vary in time depending on what your scan settings are. On average, they take between 7 to 9 minutes per plate. When CellAssist is finished imaging the plate, you simply remove it and put the next plate in. CellAssist can run continuously. As the images are captured, they're sent to the workstation, where a full analysis can be conducted. In our first example, researchers were growing 2 different patient-derived stem cell lines, and they were testing several different media. In this view, the graph is showing confluence percentage over time, and we are viewing by cell line. The cell lines are represented by different colors. CellAssist's advanced imaging algorithms automatically determine the confluence of your samples. We will select all of the passages in this project. The graph now shows all of the passages for the 2 cell lines. Each dot represents a scan. Hover over the lines on the graph, and you can see that cell line's project information. We can also view by passage. The graph now shows the growth of each of the individual passages over time. Hover over a line to see that passage's information. When one of the cell lines is excluded, the graph changes accordingly. You can also view doubling rate as a bar graph. Upper and lower thresholds can be set to remove outliers and spurious data from your analysis. Upon resetting the thresholds, the graph and bar chart automatically update to reflect the new selection. In this real-world example, the analytics workstation revealed some interesting characteristics that the researchers had previously not seen. Based on these new findings, they decided to revisit the earlier work using the capabilities of CellAssist. In this example, the sample's image was captured once every 24 hours for 4 consecutive days. Hovering over each thumbnail highlights its corresponding point on the graph and shows the confluence percentage for both inner and outer ring. Click to view the full screen image. In addition to the project information, scan date, and illumination type, the confluence percentage is also listed above the image. You can zoom and pan around the image using standard mouse gestures. In this example, we're using phased contrast illumination. With this type of illumination, the image is brighter on the meniscus. You can still see a great amount of detail. We can see what appears to be differentiation occurring in this area. With CellAssist, you can view earlier scans of the exact same location to see what your sample is doing over time. The bar at the bottom of the image allows you to go back and forth through the scans as they occurred in time. The most recent scan is at the right end of the bar. We can go back in time, scan by scan, to see when the differentiation occurred. CellAssist maintains focus and accurate positioning as you zoom and pan over your sample. You can define an area of your sample and export all the scans for that exact area to share or use in published papers. The images are exported along with their information. In addition to manually clicking through time, CellAssist can play the images in sequence as a time-blended movie. You can even export this as an MP4 movie to be played in any standard media player. In this example, the researcher wanted to inspect and document morphology of the colonies, and then passage-only undifferentiated monoclonal cell colonies. CellAssist makes it easier to identify colonies and track their growth over time by outlining the colonies for you. Click to show the outlines. CellAssist keeps track of each of these colonies in the colony list on the left. The colonies are listed in order by size, with the largest colony size and the colony count listed at the top. Click on a colony in the image area. CellAssist automatically centers the colony in the image window, and the colony list automatically scrolls to that colony's entry. Notice that some of these colonies have different colored outlines. CellAssist initially outlines the colonies in white. Then you can go in and assign each colony a rating, which will change its color. And you can write a note. We've noted that this particular colony appears to be monoclonal. All of this information is saved. You can go back and forth in time to compare the cell images to their outlines. Just as you can go back and forth in time with the cell images themselves, you can also go back in time with their outlines. You can see how a colony grew over time by manually clicking through the scans. You can even view this comparison as a time-blended movie. With state-of-the-art imaging, advanced analytics, plate management, and laboratory tracking, from initial plating through final analysis and publishing, researchers are turning to CellAssist for the accuracy and repeatability that is essential for modern research. We're proud to be helping biologists worldwide get the most out of their research. We look forward to finding out how we can help you get the most out of yours. What can CellAssist do for you?